And we're back for for day 18 of Advent of Code. Twitch is like, what the fuck are you doing? That sounds dumb. But it's for YouTube. For YouTube, we're gonna have 2 videos. Gonna look separate. But it's fine. Don't worry about it. But yeah, we're not gonna finish up the PHP. We're not gonna have time for that. But we should get set up for day 18. JL says, and I'm back. Yeah. Babby is an awesome name. Yeah, I really know. The name came out accidentally, and I really like it now. It was originally a typo of Nano. But no, I like the name so much that I stuck with it. And actually, when I was coming up with names for the editor, I had like, actually, I think this is the only one that I considered, and I was like, done. That one. That's the name of the editor. But yeah, I'm really happy with the name. But yeah, you're right, Sidecode. It is a misspell. But yeah, today's challenge is released very soon. We'll close some of these PHP tabs. Oh, we closed the puzzle. Whatever. Whatever. I didn't count the. Oh, we closed the whole window. I know what I'm doing. I'm good at this. Actually, didn't I do some work on part 2? Oh, look at that syntax editing. Weird. So weird. Yeah, we implemented calculate path. And I'll finish that probably after we finish day 18's puzzle, if we finish day 18's puzzle. Yeah, the PHP is pretty gross. Start implementing day 17 part 2 in PHP. Okay, but yeah, we gotta get ready for day 18. We're gonna try my new template today. We didn't get to use it yesterday because, or we didn't use it. Wait, why? We didn't use it yesterday because it was int code. We didn't use it the day before because the parsing was simpler. But I'm gonna bet that today is not int code, and I'm gonna bet that today's parsing is more complex. So we're gonna try this template out. If it doesn't work, it's fine. I just delete these lines of code and this line of code, and then we're back to what we had before. But let's see, cp-r day 0 to day 18, and cd into that bad boy. Move template.py to part1.py. And we will open that in our editor, situate ourselves here. Get ready to go there. What do we also need to do? Day 18, we will open up input.txt and we'll set up our inotify exec with part1.py to run pytest, and then I think that's it for getting ready to go. Typo maybe plus x equals s. Oh, and this is just like this is just placeholder. Because eventually what I'm going to have to do is like xy equals something like xs, ys equals s dot split, I don't know, this, and then x comma y equals int xs, int ys, and then something like this. Like that might be some transformation that I do to implement a parsing there. But it's not like exactly what's going to end up there. But yeah, it's just placeholder. But yeah, you're right. Like it is a typo, but it's intentionally a typo. It'll eventually get fixed. Sidecode says still waiting for the next day. That's true. I'm actually going to fill up my water before we start. Knowledge says, weren't you meant to not be streaming anymore this year? This is the last stream. This is the last day that I will be streaming. I might have misspoke before. I think I said penultimate or instead of ultimate or like second to last or last. I don't know. This is the last stream. I promise. This will be the very last one. Unless some freak of nature happens and I get good internet. But yeah, I'm gonna go fill up my water and then we'll get ready and hopefully I'll have enough time. Hey, what's up? It's me, Shoosting. Thank you for the follow and welcome to the stream. But I'll be right back. All right, we back. Knowledge demands and Anthony Wright's CodeBot breaks his promises. Have you figured out how to, Michaela figured out how to break the bot earlier. But that's good. Psycho says, sad, I look forward to your streams. I unmuted, right? Yep, we're good. I am the quality streamer. I know what I'm doing. Yeah, well, I'm glad you look forward to my streams. I'll be back in the new year. So unfortunately you'll be without your Anthony Wright's Code content for a couple weeks, but I will be back. I won't be gone forever. And we'll finish up Advent of Code when I get back. So I'm gonna try and not spoil myself and avoid looking at solutions and problems and whatever for Advent of Code. I'm just gonna la la, I heard nothing. You told me nothing. So I'm gonna try and not spoil it so you guys can see my actual reaction and approach to solving these problems. But that also means when we solve them in January, I won't have to be in the like, not gonna look at chat, gotta go fast, like zoom through this problem. I'll be able to like chill and relax and talk with chat and like have a nice normal stream instead of the normal like go fast. But you won't get points. Yeah, I'm not gonna get points. But you know what? I got points more times this year than I thought I was. Like, I'm pretty happy with the amount of points I got. I got points on 1, 2, 3, 4, 5. I got points on 7 parts. Well, that's assuming we don't get points today, but I don't know. I think we might be able to get points today. There's a small chance. Depends how complicated the problem ends up being. Oh, that's weird. This is what I got back from your message, Nowledge, where you used /me. Yeah, we get this like weird action thing out. But I don't get anything for the like channel points thing. There's like no special highlighting. Like this was a channel points one, and this was a channel points one. So the action demands action, right? Yeah, it's a little bit weird. I don't know why it does that. Ooh, my heat just turned on, but it's actually cold. Hopefully that warms up because it's a little uncomfortable. But yeah, we'll be back in the new year. We'll be working on that. It's freezing. Yeah, it's so cold outside right now. A solid 9 Celsius, 48 Fahrenheit. It's yeah, it's cold. Today was cold, very cold. It looks like it'll warm up the rest of that, but that's still pretty cold. Glad I didn't go for a run today. Action defense, action defense, action. Right, Pythonic Pie? Alright, got this tab open. We're ready to hack on this code. Actually, we'll put the cursor here because I think that's probably where we'll get started. We'll paste our input in here, and then we'll be off to the races. Michigan's weather is worse. Yeah, it's gonna be cold. You don't use your computer as a heater mining Bitcoin? No, I don't do crypto. Crypto's a great way to ruin the environment. As much as, like, I don't know. Streaming programming on the internet probably isn't too great for the environment either, but at least it's not just like pissing away electricity for fake internet money. Well, it's not fake internet money, but yeah, whatever. I just angered everyone in chat. They're all leaving now. Alright, 6, 5, 4, 3, 2, 1. Let's go! Puzzle input. It is a maze. Okay, so our parsing approach is not going to help us. Holy shit, there's a lot in here. Okay, so we don't have those. That's fine. Grid. Probably use a default dict. 4-line in s.split lines. Y, comma line in enumerate for x, comma c in line grid y, comma x equals c. Well, we'll print the grid if we need to. All right, what is this problem about? Got our parsing done. As you approach Neptune, a planetary blah blah blah. Make this a little bit bigger. Only one entrance marked at is present on the tunnels. The tunnels are too narrow to move diagonally. Okay, we gotta move straight. Only one entrance at is present among the open passages marked dot and stone walls, but you also detect assortment of keys shown as lowercase letters and doors shown as uppercase letters. Keys of a given letter open the door. You aren't sure which key you need to disassemble the tractor beam, so you need to collect all of them. Okay, collect all the keys. Gotta find the key, gotta find the key. Okay, so we're at, in order to get through door A, we gotta go to A, then go to door A, then B. Okay, cool. Starting from entrance at, you can only access a large door A and key A. Moving toward the door doesn't help you, but you can move 2 steps and collect the key, unlocking A in the process. Okay, so whenever we touch a key, that resets all the doors. Got it. So collecting every key took a total of 8 steps. Ooh, so we have to do minimal paths. Oh, this one is gonna suck. I don't know anything about pathing algorithms, so maybe we'll get away with depth first, which is what I usually do, but we'll see. Oh, damn. We have to get complicated with stuff. Hey, what's up, Ethan? Big gifts don't cut it anymore, right? You only end up in third. Holy shit. Okay, this is gonna be... I'm not getting points today. I don't know anything about pathing, so we're gonna have a hard time on this one. I get the paper out hand solving today, right? You're allowed to hint, but I don't really like hints that much. I might ignore them. Breadth first would work just fine for this. Would it, though? It would work fine for finding keys, but that doesn't necessarily tell us which key we'll find first. And I need to breadth first after each key find, I think. The answer is C, right? Breadth first finds the minimum. Yeah, it would find the minimum to any of them. Okay, let's use this example and see what we get here. So we breadth first, we get blocked here, but we get to A. That unlocks this and this. Then we breadth first, we get blocked here and get to B. That's cool, we're here. Then we reset everything, we're breadth first, we can't do this, so we get to C. That's fine. Then we breadth first. We would actually reach key E. Yeah, here's the problem. While E is closer, it would be slower in the long run than collecting D first. So that doesn't actually help us in that case. Although I guess we could just keep each path. We could keep each path around and just keep traversing until the end. Yeah, so breadth first actually does kind of help us here. Okay. So maybe that's not the worst. What do we have to keep track of? We need to keep track of what keys we have and our position and the count. That's not so bad. Okay, breadth first. Let's do it. Let's go. States equals no keys. Well, no keys. Position is if C is equal to at, then position is equal to y comma x. But we want, why did I do y comma x? All that curses is getting to me. Pause and 0 steps there. Okay, so while states, actually, how many keys do we have? Well, true. What could go wrong? For next pause for let's see, for keys, pause steps in states. For candidate in next pause, pause. Oh, the music stopped. What's the eyeballs one? If grid at cand is equal to dot, then states next dot. Oh, but we need to know whether we visited that in this path. We don't want to backtrack on ourselves, otherwise we're just going to blow up our state space forever. We actually need a visited count too. Visited set. If... And we need that for each count? Yeah, okay, alright. If... Why are these indents all messed up? There we go. If and in visited continue. Elif grid cand is equal to this. Continue. Elif grid cand dot is upper and grid cand dot lower, not in keys. Continue. Keys, well, you can change to a set. Oh, then we need to type annotate it. Shit. We can give it a set that contains a string. We have the empty string key. No. We'll just use this and we can type annotate it later. Why am I wasting time on type annotations? Ah! Okay, so if we've already visited it, we will continue. Oh, but sometimes we need to backtrack. Sometimes we do need to backtrack. Sometimes we need to backtrack. Do we ever need to immediately backtrack? No. So as long as we keep track of the previous one, we should never... Yeah, so we should only go in one direction. We'll just call this prev. We don't want to go back to the previous one. And we can just use a dummy value here, doesn't matter. If candidate is equal to prev, then we continue. That'll call those ones at least. It'll keep it going in one direction. And our grid lines are small, right? Yeah, they're never too wide. No diagonals. Cool. It's upper, and we don't have the key. Then we continue. Elif. Yeah, otherwise it's fine to go on. If grid... Just making sure that this is neither upper or lowercase. Let's see. If C dot is lower, then can we mutate these? Yes, because we're deleting them afterwards? No, we can't. Add the keys to the set if we get the key. States next dot appends our big ol' blob here. Keys. Previous will be pause, and then canned will be the position, and steps will be steps plus 1. And I think that gets us that. We need our termination. If len of keys is equal to key count, return steps plus 1. Alright, let's see what this does. Do we want the smaller input? Let's try the smaller input. Not enough values to unpack. Definitely type. Okay. Oh my god. What are we doing here? Why we go forever? Oh, because we don't complete our iteration. Still taking a while. Debugger time. You're not moving pause. Yeah, it should be. It should get moved. This is the previous value. This is the next one. States is that. We have no keys. Okay. States is now this. We moved to 6-1 and 4-1 on our diagram. Oh, but we never... Huh. If we get a key, previous should be just some garbage number because we can backtrack in that case. So that's the problem. So if we retrieve a key, we're allowed to backtrack. We'll just give it some dummy value. We got a 8. Is that the answer? Yeah, it is. Sweet. Yeah, let's try the actual one. I'm cocky, right? Took long for a while we copy and paste the other example. $86. Cool. Here's a few more examples. 132. I'm concerned with how long this is taking. I'm concerned with how long this is taking. Oh, because we bounce back and forth when we get a key. Okay, so let's terminate that, because otherwise we're just gonna run out of the RAMs. We're just gonna keep building up. And C not in keys. Only in this case are we allowed to backtrack. Okay, that goes fast and gets us the right answer. Let's look at the next one. 4.text. One takes a little bit longer. 136 steps. It's quite slow. Very, very slow. Also, maybe infinite looping. Hard to tell. Let's print the length of the states each time. Yeah, it's exponentially increasing. That's not good. Why? Why you do this? Gotta prune, yeah, that's the problem. So we gotta figure out why we're not. Oh, we're probably getting to a previous state sooner? Oh, we can just delete... Oh. If one has more keys than the others, we can delete all the other ones, right? That's one optimization we can make. Also, they'll all have the same count. Is there ever a case where you retrieve 2 keys? Like, you could retrieve 2 keys, but... Oh, this is so complicated. I see why it's, why it takes so long. Because there's a lot of branches you can take. And the combination is tricky. You gotta bounce around here. But also, this is gonna take all my memory, so I'm gonna kill this before we run out of memory, and then and then lose this. Shit. Huh. Are there any other termination conditions that we can consider here? We're at least not backtracking, but this sort of structure causes us to generate a lot of stuff. Like after the first iteration, we should have these two. And then we have 4, 5, 6. We should do 2, 4, 6. If we're not doing that, then something else is wrong. Have it up here. Yeah, why does it get so large so quickly? Maybe go back to your visited set. The problem with visited is like we need to be able to backtrack. Like in this example here, we need to be able to go to D, we need to travel to D and then travel back. So previously visited is not quite right. We at least have our exception for when we double back on ourselves directly. Visited could be keys, comma, pause. Oh, that's true. Yeah, that's true. Although sets are not... I guess you use frozen set. And actually, this should be frozen set as well. A set containing a frozen set. Let's try that. Yeah, I like that. Visited. Elif keys, comma, canned in visited. Continue. Parentheses around here. Don't need to do this shenanigans anymore. Okay, that gives us a frozen set. Cool. This also needs to be a frozen set. Yeah, because we need to modify it. Frozen set containing that tuple, so... few parentheses here. Put a frozen set in a hot loop, it melts. Yeah, probably. Should keys be a tuple? Order might matter. Does it matter? It's a good question. Let's try it without it. Alright, we gotta get rid of that. 86 for that. That was right. T2.text should have been 86, but we got 84. How the fuck? What? First one should have been 8. Oh. Oh, yeah, you're right. First one should have been 8. What the fuck happened here? Add 2? Is it always exactly off by 2? 8, 86, and then this one should have been 132. No, it's off by something more than that. Are we walking through walls? Is that the problem? Oh, we're walking off the grid, maybe? If and not in grid, continue. How in the world? Alright, we gotta get the first one working. Clearly that's wrong. This is so hard to see with the present set. Okay, so we start with our initial state, which is at 0, and then we get to here, which is at 1. We retrieve key A at 2. How do we already get to key A? Oh, that makes sense, yeah. And then... who got the key here? Who got key B? So we should have had 2 steps before we got A. We did. And then we should have gone... Oh, I see what happened. I see what happened. We reassigned this set, but it's visited out here. Now we're at 9. Okay, let me remove the prints, because those are pretty slow. Okay, so 8, 86, 132, and then this one is 136, but this was the super slow one. It's still super slow. So verbose, yeah, because Frozen Set doesn't have a short rubber. What is this bug? Frozen Set literal, yeah, this was not gonna happen. Yeah. Also, wow, this is so slow. Are we not culling properly again? Yeah, we're building up exponentially. So I think we need to call if we get to a position that we've already visited that has a particular set of keys. So we can say we can store visited globally. A dictionary mapping to. Oh, actually. Yeah, we just need a set of of this. We can just store visited like this. We don't need visited on each path. That should keep it from blowing up. $136, cool. Alright, is this fast enough to run our input? Copy the next problem while that's happening. 181. Oh, 4544. I did not do that fast. Oh, we still got points? What the fuck? I'm thoroughly surprised that we got points there. We also got a lot of points there. You arrive at the vault only to discover there is not one vault, but 4, each with its own entrance. On your map, find the area in the middle that looks like this. Update your map to instead use the correct data. Fuck. Points, hell yeah! Okay, so we need to find our start position and modify it. I can now retire happy, right? Points! It feels good to get points on the last day. Alright, let's see what we do in here. Okay, we modify it into 4 things because some of the keys are for doors and other vaults. Wow. This is gonna be tricky. Okay, so we control 4 robots and we can choose to move them each at their own independence. I guess we can still use our breadth first search and we just fork it 4 ways. Oh, this is gonna blow up very, very quickly. We kind of need to know which key we need to get next. Ooh, Trixie Trixie. Map each quadrant. Yes. I don't actually need to. I can just treat each of them independently. Kind of. Time for some AI. I mean, we already wrote AI, right? right? Okay, we need to adjust our map. That's the first thing that we can do. That part's easy. What do we flip in here? We're modifying all of these positions. Okay. diagonal from there? Yeah. So we've got... So that's top left, and up here. And then we have y minus 1, x plus 1. Actually, put these on our own line. We can just dupe these. And then we do plus 1 and plus 1. Those are our 4 bots. And then we need to set a plus to be that. Alright, would it be slow enough to do each of these manually? Let's see how big our map is. What does it look like when we adjust it? Where's the at? That is not at, this is at. Okay. Oh, it's very tricksy. Did I type Grod? I did. Thank you, Michael Fox. Oh, this is rough. This is real rough. It does at least split it into 4, so we can tackle each problem independently, kind of. We could try each quadrant. See, the problem is they said sometimes multiple robots will have keys available, or a robot might have to wait for multiple keys to be collected.
Here's the truth. Somehow you can hate me. I don't love you anymore. I don't want to lie.
We can split this into 4 problems and try it repeatedly, is an idea. And like find all the keys in each quadrant. I kind of like that idea. Kind of divide and conquer. Map the key door combo in each quadrant and generate a requirements list for each robot. Yeah, I'm not sure how that quite helps me. I do need to know which keys are in which quadrant, so we can start by doing that. Oh, but it makes no sense for this robot to try and get keys from here. But these can go in any order. I wonder if it would be helpful to build a DAG for keys. Maybe. I think I can do it by just alternating trying each robot to get to keys, and if it can't reach any keys, then it will raise an error, and I can just try the next one, and I can just keep routing that way. That's what I'm going to try and do. That is what I'm going to try and do. But I need a way to like mind map that kind of. Like I basically need to be able to say, hey, robot in top left, go retrieve a key. If you can't retrieve a key, fine. Then we'll try robot in top right. And we'll keep repeating that until we get all of the keys. Oh, but also... Oh. I bet even... Like, even with this quadrant split here... this probably has access to more than one key. Yeah, there's 4 robots, yes. I'm gonna try my bad solution first and see how many of the answers that gets before I start like trying to build DAGs and stuff. So... keys and position. We won't bother typing. Grid. And yeah. Oh, forgot the update. We did that. Or we'll put it back up. So we'll return none in the case when we don't hit a key. Otherwise, we will return a key and the amount of steps it took. So we're really just having a robot find its nearest key. We need to return its key, its position, and the steps it took. Return C, the position, canned, and the steps. Steps is 1. And we're never modifying keys, so we can get rid of this here. We'll just keep it. That doesn't do anything. Alright, we will try something like that. All keys is less than... Oh, we need a new visited. We need to copy visited each time. We don't actually want... we actually don't want to modify it. So we'll change this to frozen set in a sec. Or we'll type it as a frozen set. While the length of keys is less than the key count, for bot in bots. Actually, we need bots and steps, probably. Bots, position, and steps. How many steps that bot has taken. Mailbox says, I wish I was on break already. Yeah, I'm about to peace out for the rest of the year, right? Get key. This also needs to return its new visited amount. Actually, no, it doesn't, because we gain keys from that point. So we don't really care about that. It's gonna be slightly slower, but whatever. Wolf says, seems like a difficult puzzle this time. Actually, the first part wasn't so bad. It's this second part that is a little bit tricky, but I think I have a good idea on how to do it. Ret equals get key. What did that function take? Key pause grid visited. Keys pause grid visited. Where'd my loop go? Here we go. Keys is a frozen set. Pause is the bot position. Grid is that, and the visited is this. We don't actually care about visited. Do we? Yeah, we kind of do. So we'll return visited as well here. That'll help us go faster. If ret is not none. Give it a copy of that. If ret is not none, then keys equals keys and C. And what was canned supposed to be? Position? Yeah, then I bot in enumerate bots. Bots I is equal to bots I is equal to canned. Oh wait. Ret 0. Ret 1. Steps equals 0. Steps plus equals ret 2. And visited equals visited. I'm gonna try this. We're gonna see what happens here. And if oh, we already have our while condition. Cool. Return steps. All right, let's try this on that small example. Oh, but they didn't draw it right. They drew it after it got mutated. We gotta unfuck this. I think this is the simplest unfucking of this. My code will just fix it. What are we getting here? Whoa. That's running for forever. Oh, a bot found something. Oh. We took away all the keys. It never makes it through the first loop. We got another stuck bot. Why do we got another stuck bot? Oh, because we didn't give it the right keys here. The keys. What the fuck? Oh. What was the answer? Was it 24? Oh fuck yeah, it's 24. Okay. Okay, that sounds good. We got a number. What the fuck? It's someone else's answer? No! Shit. What? God damn it. Alright, let's try this next one here. Everyone watching this tries entering that number, right? Okay, cool. So, we at least have a failing test, so that's good. Damn it, Ethelbert, don't you fucking do that. The first part wasn't so bad, meanwhile I'm clueless on how to even approach it. Yikes, yeah. I had my hopes up. Yo, my heart was beating, man. Beating. Okay, so I have another idea that might make this better. So like the tricky part here is you might go shorter on something, not just like doing it in order might not be the best approach. Oh, like interestingly, this could collect E before it collects A. Or it could collect A before E. Hey, what's up, Zero Cool? Thank you for the follow. Welcome to the stream. I guess what I should do is I should make each bot collect all of the keys it could possibly collect, and then return. instead of just collecting the first key. Let's try that instead. Does that always give the optimal solution? Let's figure it out in this case. No, it doesn't, because I think this actually goes up here and then comes around. Top left collects D. Top left collects E. Top right collects H. Bottom right collects I. Yeah, it sounds like they're solving it like a DAG. Top left collects AB. God dang it, right? What does the leaderboard look like right now? How many have got it? never happens because it's a default dict. If C is equal to, or if C dot is upper, or, well, is alpha, right? That's a thing. Scene dot append. Oh, but it's not. It's what we've seen on a path. Not, because like you could see one over here and then one over here, and those are not dependent. Really, we have a path. Actually, I think about depth first here, right? Because we want to go until we're at a dead end. And that path is the dependent trace. So that's actually not so bad. Path, comma, pause equals states dot pop. So instead of a queue, we're using a stack. For next pause, for canned in this. If canned and visited, continue. If let's see, C equals grid pause. If C is equal to that, then we also continue. Whether continuing case that we had before. Visited, off the grid, visited, this, or door, and we don't have a door, but we don't care about doors right now. Okay. If C dot is alpha, path equals visited dot add candidate. And we know we're at a dead end if this doesn't do anything. Seems awful. Let's see if it does what I want it to do. Just run it here. Trace keys. Bots 0 grid. Hey, what's up, Nick Zaza? Thank you for the follow. Welcome, welcome. We're in Cirrus mode right now, where I'm trying to get points, but hopefully you can enjoy some of that. Cannot unpack non-iterable object. Excuse me? Oh, this should have been a tuple. No paths. We never got to a paths. How is that possible? T-Bud T says, what did you do for part 1? I did a breadth first search. With some, like, modified visited states. What do you mean? We never hit a dead end for that. We did not visit many spots on this. What was T3? We should have definitely hit these and eventually got up to here. But we only visited a couple of squares. Oh, I forgot to append to the states. Duh. States dot push. This is not a true breadth first or true depth first. Because we should immediately, I guess we would break here. Yeah, that would. Oh, but then we wouldn't get it eventually. That's fine. It probably doesn't need to be truly depth first. Also, we're only ever going to add one anyways because of the way our paths work. States.push. Canned path and list has no attribute push, right. This is not JavaScript. We end up with quite a few in here. But that's because it's not truly depth first. I guess we can do this recursively. Just one breadth first search? I end up doing a shitload. Essentially one for every combination of open doors. Yeah, just one. This was my part 1. Just this is just one breadth first search. For canned in, let's see, dead end. Actually, we can just copy paste this code. Did you do part 2, T-Bot T? I assume you did, because you're usually pretty good at this. Imposter syndrome intensifies. Yikes. But you've already got part 2, so presumably. But presumably you're better at this than I am anyway. Canned path, canned grid visited paths. If dead end, paths.append path. What the fuck am I doing? I made number 23 for part 2. Nice. That's because I ran it with PyPy with a shitload of caches. It took less time, but I've come up with a better solution. Nice. Well, mine doesn't work at all, so. Trace recursive takes path to get there, the position, the grid, visited, and paths. We should not do these empty ones. So why do we end up with dupes? Why do we end up with lots of dupes? We only care about the unique paths, I guess, though. Vader Tools docs have a nice recipe for unique Everseen. Huh, interesting. So how did C reach a dead end, is what I wonder here. Six 2 and 7-2 is a dead end. We started here. This is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. So I got to hear somehow? Oh, fuck. That shouldn't have been possible. Should have started here. And should have skipped that one. That was great. That was, of course, exactly what I wanted. Oh, I see why. So maybe the old code did work. That's the only path that we get there. Alright. Hey, what's up, Meow Renfei? Thank you for the follow. Welcome to the stream. Okay, so all of these, D is dependent on all of these. What we get for that. I hate using iter tools. It means I've failed. I need to listify this one. No, iter tools is great. I just don't like iter tools. Oh, don't even get me started on more iter tools. I've had so much pain due to that package. Do you consider using a library for like A-star cheating? No, but I'd also rather like kind of implement this myself. Okay, so from this we see that we have 3 that are uninhibited, but we have 1 that requires this. This is the less interesting problem. Let's look at T3. This is what we end up with. Actually, let's run it over here. And look at what they got. So they picked E first. Even though A and B are available here. How did it know to pick E over A and B? Problems is my problem. We know the top left bot had to do something. Maybe that's just one of the choices it could have taken, and I really need to consider all of the paths that it could have taken there. Actually, maybe my original solution isn't so bad, but I was only considering one of the keys. But if I consider all of the keys and keep those as separate paths and then figure out which one completes first, that might be a good idea. Hey, what's up, MSG Trip 5? How's it going? Let me go back to my first approach. We'll just do some more breadth first search, because that is what I'm good at. grab the keys. We need a new tuple. Actually, we can just do a slice. So bots :I plus dot pause plus bots I colon. Is that how that works? Probably not. I need a +1 somewhere. Yeah. Do I +1. That'll be our new bots. The new steps will be steps plus got steps. And the new visited will be got visited. Let's try this. Yeah, fuck. Alright, we need to call this function. Well, we're infinite looping somewhere. How did we get to a state where we didn't get more keys? Something's real messed up here. What do we have here? What does this represent? We have our keys, we have our bots, we have our number of steps, and we have our visited. This needs to be a couple. And our visited up here is what? Keys in the candidate. Okay. Why didn't we acquire any keys? Oh, because we never update our states. So it looks slow because it does this exponential thing, which we tried to fix before, but didn't really do so well at fixing. But did we get the right answer is the question? 24 steps. Yeah, that's what we expect. Let's see what it gets for the next one, or if we blow up exponentially again. So 24, 32, 24, 32, and then this one should be 72. We get 80. Damn. Well, that's further from the solution. It's so close. Yeah, you're right. I guess we could just say, like, I mean, we do have a thing that will trace out all of the answers, so we can append them to this list and then return the minimum of that. Oh, the music stopped again. So we get the right answer there. How fucking slow is this gonna be? Probably too slow. We are already consuming 5% of my memory. Oh, I suspect this one is not going to be our winner here. Which means we need to look at this one again. Yeah. Let's let it run to like 50% of memory and then we'll kill it. So we got 1 minute to wait. What's our leaderboard look like? How many smart people do we have so far? Oh, there's still points are available. So if I get this clever enough, then I'm proud to say I've thrashed my computer to death twice during Advent so far. I've been pretty good about not thrashing it. Also, this is a VM, so like, worst case, we lose the virtual machine. Which is not so bad. But something about my states is probably blowing up out of control here. My day 3 still takes 45 minutes to find the wire intersection, so... Oh no. I felt like day 3 wasn't that bad. Okay, what was day 3? Look away if you don't want solution. I'm gonna spoilers for a sec. Oh yeah, this was the okay, I remember this one. Yeah, okay, I could see how you could take a long time on that one. Okay, we're killing this. Back to debugging. Are there any larger examples that we got here? Here's an example with more choices. Perfect. This is the one. Oh, we just did that one. Fuck. I've had worse things happen to me while using virtual machines. My solution took 1.5 minutes for part 2. Okay, well I just got to 2 minutes. You were using PyPy also, so maybe if I try PyPy it'll go faster and get there. But PyPy takes more memory, so... Are we gonna heat death my computer? We will find out. Well, we're certainly getting memory faster. So that's a thing. Hey, what's up, stranger? Thank you for the raid, friendo. How's your day going? How'd your stream go? We do the raid, right? Right, Define Evil? Memphis says, hello, Snake Lover. It's not that I like Python, it's just that it's my current choice of poison. Apparently you're a snake lover. Thanks, Emmy. And it might be innuendo. No, I'm not a fan of snakes. It's not my jam. Snakes are icky, venom not poison. Oh, did I say poisonous? Really? Oh, I see. No, you're correcting my bad joke. I see now. Hey, what's up, Memphis? Thank you for the follow. I just had to rewind time a little bit to get to what you were saying. Yeah, it's acquiring memory about twice as fast as CPython was. Yeah, we're up to 3 gigs. How much memory did yours consume, T-Bod T? Rather Python than C++, to be honest. That's fair. Alright, I have to kill this if I get to... Oh, I actually have to kill this now because it's about to start swapping. Okay. Okay. I could give my VM more RAM and just let it run. Hey, what's up, UberX and Moskatops? Thank you both for the follow. Welcome to the stream. So my problem is that we're revisiting states, I bet. Message 555, I've been switching, mostly encode in Python, everything else C++. Yes, reuse your solutions, right? Stranger says, have you played with beeps, aka channel points? They exist on my channel. I didn't enable them. I don't know what I'm supposed to do with them. They just showed up one day and now they're a thing, so I don't know what I'm supposed to do. A bad streamer. Amy says, how much RAM have you given your VM? 8 gigs. UberX says, playing catch up with admin code still at day 8. Bang, still no dynamic memory. Right? Oh. Wait, this is part 1. What am I doing? We need to stop iterating here. Oh, we do. We do else there. Muskatup says, it's nice being here. Thanks for your kindness. Well, happy to be kind, you know? That's what it's all about. Yours took 140 megs. Okay, so mine is clearly acquiring way more RAMs than it needs to. I guess one thing that I could do, I could share the visited states. And prune that way. Have you gotten to the second language yet? No, I haven't even done the first one. Pyrofloidian says, do you have like a basic bio? Software engineer. I work at Lyft. I work on infrastructure. I do Python stuff, mostly a bunch of open source stuff with code formatters and linters. I run, bike, and climb in my free time. I don't know, that's my basic bio. Live in San Mateo. But no, I haven't put anything up. My website is hilariously out of date. But if you Google my name, most of the stuff that comes up is me, so you can find that. Tinder profile, right? Yeah. Talent Division says, I've been doing AOC and Julia. The standard limit is pretty great for it, but I'm still learning Julia, so my times are non-competitive. That makes sense. Hey, what's up, Demoxity? Thank you for the follow. Welcome to the stream. Emmy, did you swipe? Which way? No dynamic memory in int code. Seems like it has infinite memory. Oh yeah, we were talking about no dynamic memory for my VM. I climb at what is it called? I climb at Dogpatch Boulders in San Francisco. I'm 28 years old, Pyrofloidian. 90% of people doing ASC live in Silicon Valley. Interesting. Secret. Okay. That was a guess, not a fact. Oh, okay. Prency here. I wonder if I'm just like re-retrieving bots over and over. This shouldn't be that slow. Yeah, loop expert. You should have seen my part 1. My part 1 was pretty hilarious. It was definitely like loop expert dealio going on there. Oh wait, no, I got rid of my fun else break thing. Maybe that was a different day. Oh no, that was day 17. Day 17, part 2. Where was that? Yeah, here we go. Break, else break, else break. Some loop shenanigans going on there. Oh no, here it is. Break, else return, else raise. Some good loop there. You don't actually care about the steps. You just care about the bots and the keys. If can keys, can bots in visited, menu, visited.add, can keys, and bots. $24, $32, $72. This one still takes forever. Memory's still growing pretty rapidly as well. See how quickly this expands outwards. Damn, that's pretty slow. Hey, that's pretty slow. My response to any Python program. Yeah, or Ruby, or JavaScript, or PHP, or... pretty much all those languages have the same problem. Interestingly, these aren't that large in numbers. But we're consuming quite a lot of memory. I wonder if it's keeping track of these visited counts that's super slow. Or it's super large, I guess. Chunky. This one terminates pretty quickly. Even though it has quite a lot of things. Interesting how that seems to go. Yeah, true is equal to 1 in Python. In fact, in really old Pythons, there was no true and false, and you just used 1 and 0, and so many programs would start with this bit of code. Alright, do you guys think I should give my VM more RAM? And run this with PyPy and see what happens? Maybe I just stop copying this in, because I'm not sure that this is actually that useful, and we're not really getting... I think this would make it faster. For 32 80 80 what 80 no 80 no not this again. Well, I can undo what I just... oh shit, I closed it. No! Fuck. Fuck me. Really? It was 72 before. PythonicPy says, another fun fact, you can't create your own bool subclass in Python. I bet you I can. Or I bet I can make a none subclass. Let's see, Trusty would be old enough? Yeah. Trusty, why are you going so slow? I'm just trying to prove a point. We don't have time for this shit. I can close that tab. Oh, I should have done no install recommends. This is gonna take forever. I guess I can say no to the prompt and then no install recommends. Leaderboard is still not full. Interesting. Why do you need an old Ubuntu? It's part of the thing. It's because it's a bug that's gotten fixed. Hey, what's up, Bobby Flay? How's it going? Don't mind me, I'm just wasting time for a dumb meme. I know how to use Nix, I just refuse to. How did this work? Make a class, and then you can make another class which inherits none type? The other way around? Oops. Is it new style object? Let's do this again. So this way around? Yeah, there we go. We now have a D that looks like none, or it inherits from none. That none type in its MRO. But yeah, this is a bug. It got fixed in some version of Python. But anyway, wasted all that time for a meme. I assume you're trying to solve this without hints. I mean, kind of. Hey, what's up, Sarcastic Dante? How's it going? Bobby Flay says, not much, man. I actually came across your channel from a Reddit comment, starting to teach myself, and someone recommended your Twitch. Oh, awesome. Which subreddit? It's pretty cool. People repping me on Twitch, or on Reddit. Thanks for sharing that. Time to go write some obscure code, right? You wanna see some other fun stuff in Python? Check out this one. Live stream fails. Wow. False equals false in the array false. Alright, so looking at this expression, you'd think, oh, well, I don't remember the order of operations, so we'll try it with this print sized. So you get false equals false. That's obviously true. True in false is obviously false, right? Cool, yeah. Everything, nothing special there. And then you're like, okay, well, maybe it's the other way around. Let's try it with the parentheses on the second part. So false in false, this is true, and true is equal to false. That is not true. So this should be false, right? Obviously false. Cool, yeah, definitely false. But you remove the parentheses here, and it's suddenly true! And the reason for this is, well, it's kind of hard to see here, but there's a single comparator which has multiple operands in here. This actually evaluates as false equals false and false in false. Woo, spoilers. Makes sense to me, right? Oh yeah, points. We gotta get points. Try using ASP3 and we might see a skeleton waiting for the results. Right, we gotta get points. Problem is I'm keeping so much state per each bot. We're like quadrupling the amount of state that we had the first time. But yeah, you can see up here that we got to 72. Unfortunately, I gotta put the code back though. Yeah, both of them are treated as a comparator, so they, it's the same sort of deal that allows you to do like 1 less than 3 less than 6. That's a false explanation. No, it's definitely true. Zero cool. I think I actually know what I'm talking about here, for once. But yeah, it's the in operator and the equality operator are both treated as comparators, so they get chained. Fake news. I need to fill up my water, so I'm gonna be right back while I do that. Thank you, friends. I came up with another idea. Well, let me get it back to working again for the smaller ones. Because it's bad that it was not working. 4 steps. Bobby Flay says, sorry if you've already explained this, but what are you creating? I am solving Advent of Code, which is a series of programming puzzles, 2 per day for the month of December, and we are working on day 18, part 2. Huh. Oh. Is this the problem? That we're backtracking on something that doesn't exist? Oh, that's not gonna complete. We never complete there. Alright, let's go back to keeping keys and the candidates in this visited set. What the fuck? Why are we not back to our solution again? Oh, what did I break? Oh. I guess we just want to do... Huh. Rip points? Cool, okay. Message 555 says, looks like you're doing a breadth first search style implementation on a graph without unitary edge weights. Yes. That is indeed what I am trying to do. And it means that I am I'm cutting out solutions that would have worked. Yeah. When I had this original check, I was cutting out solutions that would have worked, or would have been shorter, but were done out of order. Okay, so that brings this number down and makes it faster. But is it fast enough to solve the big inputs? Unit edge weights allows you to use breadth for search, but then you have more states. Make sure we don't run out of memory here is the right here. These numbers look familiar from before. Not this tab though. This was the other solution approach. Alright, but I think I have like 2 visited sets right now, and I think one of them is not so useful. And that's what's causing my memory to balloon, and I think a lot of this time is spent in just like spending memory. Message 555 says, honestly, I don't think the input was very strong today. I mean, like, brute forcing it wasn't so bad? Like, bad solutions could get an answer, is what you're saying? I removed the main insight that lets me get an efficient solution and still got the right answer. Oh. Interesting. Did you get lucky? I got someone else's answer accidentally. That was good. Not brute forcing it, but buggy code got the right answer. I had a problem a couple days ago that had buggy code that still got the right answer as well. Right, I'm gonna kill this and try and see if my adjusting this by removing the extra sets is still correct and fast enough. But I'm gonna add it into Git so that I don't break it this time. Values to unpack. Expected 3. The right answer for that one? I just forget. It sounds right. 24, and then 32, and then 72. No, it's still reasonably fast. This is resulting in more states but less memory. Message 555 says, I don't know what brute force approaches work. There are probably efficient solutions for some, though. Or for sure, though. Provably... Oh man, I can read. Underscore Zabo says, wish I had time to think about this for longer. Dang. Hey, what's up, Saquinic? Thank you for the follow. Welcome to the stream. This number is probably just going to increase significantly. So the memory is staying pretty constant. Oh, we about triple each time? I guess that's better than quadrupling each time. Oh, this almost quadrupled though. I'm hoping that it eventually gets to a point where it starts pruning more of the stuff. Three to the 26 is still unworkable if that pattern continued. Yeah. Yeah, you're right. Oh, there's 26 letters? I guess it would try each combination of them. Well, some of the combinations are illegal. So hopefully it would start pruning soon. Oh, the memory decreased. I think. I'm reading that right. Well, we'll see what the next iteration is. my hope is that it would start pruning. Also, we can try this in PyPy. Then 2 CPUs thrashing at this problem. Is this the same general strategy you use for part A with one bot? Kinda. Yeah, roughly. But, but instead I'm not taking just the first solution, I'm just keeping all the solutions and then at the end comparing them. Yeah, we more than tripled that time. So this is not workable. We'll have to go back to the drawing board. Hey, what's up, LaFlame954? Thank you for the follow. Welcome to the stream. I think I can go with my DAG solution that I started to write. And then try each of those instead of trying all of this. I think that would reduce the number of combinations at least. Yeah, I'm gonna kill the CPython one, let the PyPy one run. Because it may eventually produce a solution, but I don't think so. Well, that's certainly weird and not what I remember this looking like. Huh. A lot of these are kind of useless. Let me uniqueify this thing. I don't think what I want. You can stop processing attempts that goes beyond your current smaller attempt. What do you mean by that, Zero Cool? Like, I think I already had that with this. Not truly breadth first, which is my problem. I think you need a different approach, but who knows what you can make work. It's true, that's why I'm looking at a different approach right now. Making sure this memory doesn't go out of control. Letting this still run. We'll see what it does. I don't think it will succeed, but... right that I want. Well, that didn't do what I intended it to do. Oh, I want sorted ret. Wait, is there just a door that doesn't block anything? There's two doors that just don't block anything? What? Hold on, let me look at this bit. Okay, so the first bot has these paths, the second bot has these paths. One of which just like doesn't block anything. Awesome. Third bot has these paths. The fourth bot has these. I didn't realize the input is so huge. I mean, it looks big on my screen, but it's reasonably large. Oh, this just keeps going up and up. How did this pattern on here? How many things are in T3? We had A through J. I had 10. And it went up to like 10 iterations before it stopped. Yeah, so this will probably get pretty large. Whatever, we'll let it keep running. Okay, so from this I can build a dependency graph, and I can know what choices I can have at each step. And how long each of those take. But just looking at this, what choices do we have? Can't walk on the diagonals? Correct, yes. Cannot walk diagonally. Alright, so it looks like we can start with either S or P to begin. Actually, it seems like it doesn't matter to begin. Like we could pick either of these. And the bots. At least this bot has to... This bot has to do S first, otherwise it's useless. This bot has one dead end, which is... There's no reason to ever go down that one. This one where it has to reach B, but then there's no reason to get H. And one where this gets E, but there's no reason to try this path. So that bot is kind of useless after that point. I wonder if I'm redoubling on paths when I don't need to, because this input doesn't look that large. Like there's not that many combinations here. See, I have about 2 hours before I have to call this one on account of time. I don't know the first way to start representing DAGs though. That's my problem. Is like I don't work with graphs very often, so I just like don't even know what to think about for that. Is it time for reinforced learning using neural nets? Yeah, if they're somehow smarter than me. But anyway, I can use this to build the DAGs that we need, or at least find the dependencies that we need. And so we can just pick off at each point what's the possible next one. We still need to trace all the paths through that though, is the problem. We also know from this which keys are in which quadrants. We also know what possible keys that can be retrieved at either point. Message 555 says, going to sleep, good luck. Well, thanks for stopping by. Thanks for the small hints you gave me. Keep praying that the PyPy solution will be done, although we can see from here that it is very much not done. So we can keep a graph for each attempt and spin out each possibility from that. We could generate all the possibilities and then run them all, I think. From this information here. Like we know bot 4 always has to go PYC. Those are the first 3 that it has to run. Always. And we know that this first bot always has to do S first. And I think... Okay, I'm gonna start trying to represent this as a graph. And go from there. But if this somehow works or completes finally ever... Oh, I already started modifying it. Whatever. It's fine. Okay, so I essentially need a function that's bot go get me this and tell me how long it takes. So I can reuse my breadth first search above to do that. That's not so hard. And we know what our paths are here. We can keep these paths for each that can be our like search state. And like, as we chop off one of these, we know all the choices. Okay, so that's how we can fork. Okay, I think we can do this. I think this is not so bad. Let's see. State is a little bit wonky though. We have keys, which is a frozen set. We have everything that we've obtained so far. We have our paths, and we have our bots, and we have our steps. And I'm still gonna do this as breadth first, even though it doesn't really matter so much. Okay, so we have 4 keys, paths, bots, and number of steps. And then we need to figure out how we can progress from there. Okay. That's that. Paths equals. Zero Cool says going to sleep. Good luck. Thank you, friend. See you around. Let's see. Paths colon I plus new paths. So write a function to get the new paths out. Actually, we can do this more cleverer with the new nice things. That's that update, and then we need to update new bots also. New bots equals if and skip that. If the keys and candidate are in whitelist or in visited, we only care about the candidate in visited. If we're on a wall, we continue. If it's a door we can't get through, we continue. If C dot is lower and C is equal to key, then we return. What are we returning out? The number of steps and the new position. We return steps plus 1 and otherwise we add the candidate to visited and we append a new state, which is our position and steps plus 1. Hey, what's up, Macabre Art Games? Thank you again for coming to the stream, and thank you for the follow. That should be unreachable. Oh wait, why did it allow me to write in both ones? Maybe... Oh, this one's modified. I haven't saved this yet. Okay, the other function that we need to implement is possible next keys. Possible next keys, which takes in keys and paths. If it's a lowercase thing, that's a potential key from one of the paths, so we will yield that and break out of this path loop. Otherwise, if it's an uppercase thing and the lowercase version of it is not in the keys, then we will also break. Otherwise, we will continue, and we'll do that for each path. That sounds about right. Let's see. Then we need to do new paths. New paths, which takes in... should just take in... Needs to take keys. New keys. Oh, well, we'll have to fix that. Problem with having two editors open at the same time is you edit in one and you can't edit in the other. It's fine. I know what I want here. So just filtering out all of the parts of the path that are inside of our key. The syntax error. Hey, what's up, Marco8137? How's it going? My name Pause. Got rid of Editor Tools again, though. Still doing Advent? Yes, still doing Advent. I'm so suspicious when the first time I run it, it does the right thing. Just did yesterday my first stream with Code Wars, problem solving streaming. Awesome, that sounds fun. Oh no, we're getting exponential again. That's not good. Did I maybe just simplify this exponential thing over here? Oh, it's very exponential. Oh. But we do know, what can we do here? We can know if we got the same number of keys before and just cut that path off, because it's probably just doing combinations. Yeah, let's try and cut some of those off. It's really just mapping the keys that we received to a number, right? Yeah, I think so. Oh, yeah. We should run the small ones first. 4, 2, and 72. Oh, I forgot to insert into that, so it didn't actually change anything. Now we produced the wrong result. So that optimization is not correct, at least for T3. Maybe I should run this new brute force solution and see what happens. Let that one run with PyPy for a while. I have higher hopes than this one. Oh, this wasn't even Py. Oh, yeah, it was. Yeah, so it's going much faster than this one, at least. Well, or at least it's accelerating upwards faster. I don't know if that's a good thing or a bad thing. Where's my thing? This thing. So in the case when there's only one, I think we know we have to take this. So we can save a couple iterations in some places with that. Catherine says, think I'm going to sleep now. Hope you have a good break. Thanks. I'll hopefully see you in January when I resume streaming, but thanks for stopping by. I'll see you around. Yeah, so I think I have to, so I think I can optimize that a little bit. That way we get at least half the problem in some cases, or quarter the problem in some cases. Because that'll prevent it from sort of spinning out of control on when it has two choices that don't matter which one it takes. The only tricky part is when it has to choose, which is down here. This is one where it actually has to choose. Same with this row right here. Has to choose. Well, I guess it has to choose this row here. Well, oh, this row. This one doesn't matter. Literally doesn't matter. But this one it has to choose. Let's see if we can do that. Oh, this might not be right. We can only do it if all of the lists start with that. Also, I just realized we don't redo these paths at all, but we should with the new set of keys. Hey, what's up, Larry NY? Thank you for the raid. Welcome to the stream, new raiders. How was your stream, Larry? Day 19 was hard. You mean day 18? Didn't get too far. Good luck. Yeah, I'm working on day 18 still. It's a tricky one. It's a tricky one. Oh, this is just gonna confuse the hell out of me, isn't it? And Kits 777 says, oh, Polar Drunken says I'm stuck on day 3. Oof. That one's pretty far back. Well, at least you got the first int code one, so that's something. Oh, spoilers, there's more int code. Yikes. Let's see. Okay, so in this case, we're only going to look at the first bot that has one possible choice. That should reduce the amount of space here. UNT says, anyone else notice that the odd number days are in code except for day 2? They gotta keep you suspicious though. But yeah, I bet tomorrow's in code also. Lower junction, I can't work out the math to figure out if the lines intersect given their 4 points. Oh, I didn't even do mine that way. I did mine in an even dumber way. I basically took the two, well, do you want spoilers or? I'll give you a hint. Hey, what's up, Sarah this cookie? Thank you for the follow. Welcome to the stream. Spoil me. I basically took two, for the wires, took 2 pointers and then followed them around, or like traced them and drew them on a graph. And then I had another one trace the other one, and only when I hit a space that was already present by the other one did I record a number, and that's how I figured it out. Day 2 isn't code. Days 1, 3, and 4 are not. Pattern works from there. Oh yeah, for sure. I tried that but ran out of heap. Well, you only have like a small grid. Shouldn't run out of space from that. Mine was like pretty slow, but it got there in the end. Wait, what? Oh. Right. What? I'm munching my data structures somewhere in here. As is a tuple of list of tuples. The paths I should be a list of tuples. And so paths I0 should be a tuple, and this should be, oh. Hey, what's up? An I or an L? I can't tell. Lina? Is it an I or an L? Can't tell. Come on, font. Let's see. Lina. Is an L. Welcome to the stream. Hello, hello. Liana, maybe? Maybe that's a better way to pronounce it? Either way, I tried. Lanai? As T-Bot-T says. I guess I can try that. It's frustrating. I know you can work out the intersection given 4 points, but I can't get it right. Yeah. I mean, the grid was kind of expensive, but it worked fine for me. It's a fictional name anyway, so no worries. Nice. So, let's see. Does it work for my solutions? Yes. But I don't know whether it's faster or not. Is this smaller than it was before? We had 5 lines plus 4. Here we had 8 lines. So it's half the size. I don't know if that's enough to make it converge. 0, 1, 6, 42, 300. So it's half the size, 2,000, 1/3 the size there. 13,000. 1/3 the size there. So it's better, but still not good. Also, each loop here, it's only getting one more bot, so it has to go to the 26th. Larry says, is 26 squared times 2 to the 26 fast enough for part 1 of day 17? Or day 18? I don't know that you can... I mean, 2 to the 26 is hilariously large. Right? Well, that's actually not that big of a number. Yeah, you could probably get it done in that amount of time. That's not so bad. Yeah, this solution has already passed this solution in... Well, it hasn't quite passed it yet, but it will very soon. So I'm gonna kill that. How much faster was it? 1 minute versus... Well, let's see when it gets to the same position. But I don't think this one's gonna work either. I think the problem is that I'm keeping so many paths. I think I need to pick one, like try one depth first, and then like try one greedily, and then like get it to completion, and then prune other ones if they go over the number of steps. I think that might work. And then I could use a prune graph for that. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Yeah, I'm just gonna kill this one. Alright, so let's try and switch to depth first then, but the same approach. So I'm just gonna have it take Alright, so we'll take in the same state. So we have the set. What is this set? The keys, the paths, the bots, and the steps. And then we have this. We don't need that optimization because we're not doing depth first. We're doing greedy, breadth first. But we also know if we get to a state and we've seen more than that, we can quit. Hey, what's up? Winston is OP. Thank you for the follow. Welcome to the stream. That's a fancy emote with your haha goose. What is that? Owl? All Access Pass 2019. I don't know what your badge is about, but it sounds cool. We need our termination condition. If len keys equals key count, then we return steps. Otherwise, we return the minimum of all the choices below us. New keys, redo paths, new keys, paths, bots, colon, I, new bot, bots, I plus 1, colon, new steps, key count, and visited. We need to update visited somewhere. So we can do it here, else visited keys equals steps. So this should naturally prune the paths as it goes. Yeah, I've been going for 6 hours, Zoomer. It's been quite a long stream. Oh, did I forget grid? I forgot grid. We have a grid in this problem? Yowzas, right? Right? Fuck, gets the wrong answer there. Damn it. Is the last stream right? Just don't want to stop then? Well, yeah, I wanna finish this problem. This what's causing us problems? Yes. We took a less efficient solution to one path, but what? Our chat says, Anthony, when are you gonna do Haskell? Maybe after break. Maybe I will learn Haskell over break. And then I will I'll do a solution in Haskell. I don't think I'm gonna do a second language today though. I'll have to do that when I get back. I didn't even finish yesterday's second language. I got very close, but did not quite get there. Oh, interestingly... Interestingly, we didn't get this one. When are you getting back? Let's see. Where's my calendar? I think I'm getting back either the 5th or the 6th, something like that. Calendar. Well, I'm flying later this morning. I'm getting back the 7th, so I'll probably... I don't know, the next stream might be the 11th, it might be the 8th or the 10th. Not entirely sure on that one. That's a lot of time without Babby. Yeah, I'm gonna probably work on Babby a lot over break as well. Okay, so this optimization is not correct. Which means I need a different way. Why is that not correct? I need a different way to stop these from taking so much work. Also, I don't have any way of showing progress anymore. Also, there's a lot of combinations, so we're gonna not do that. Line 69. How could you get to the same set of keys and have a difference, a larger number of steps? And still be a faster solution? I don't understand that part. Hey, what's up, Mediox? How's it going? I guess we could just change this to finished, and if steps is greater than finish.get something like that. going kind of smoothly. Got some stuff to do in the server room later on, but I wanted to drop in before I get to work. Nice. I don't know whether this is fast or not, though, is the problem. Like, I don't know when I'm gonna get to a finished one. Not very quickly, I see. That was today's admin code. I heard you got some points. I did get points on part 1. I'm still struggling on part 2, though. Which has kind of been my mantra for the last 4 days. 5 days. Get points on part 1, struggle on part 2. Hey look, we ran 1,000 paths finally. Oh, is that this one? No, that's this one. Almost out of memory. I think I have to kill this one. Yeah, because I don't want to run out of memory. Huh. I'm surprised this one ran out of memory so quickly, because I didn't... This was kind of the memory efficient one. Yeah, a bunch of people solved it. I'm just like... kind of lost on how to approach it, so I've mostly been just like banging my head against the wall on a bunch of different potentially bad ideas. Alright, we're gonna kill this one so I don't lose my VM. I don't think this is gonna complete anyway. Have you tried SPython PyPy? Yeah, that other one was PyPy. Probably should have run this one with PyPy. Maybe we'll do that real quick. But I don't think that's only gonna make a linear amount of change and not like fix my broken algorithm. But this should spend less time with memory thrash. It'll be stack thrash instead. It's now depth first. But the problem is we still go all the way to the end before we figure out... Well, we don't necessarily go all the way to the end. We find one solution and then... Yeah, the problem is like we're cutting off solutions too quickly, even though they might be the right one. Also, I don't know how large this number is supposed to be at the end. I could guess that it's 2 to the 26th or something like that, but like I don't even know what it's supposed to be. I can probably, I can cache. I know this function's kind of slow, so we could cache that. That might make it faster. Unhashable type, default dict. How do I get around that? No, everything has to be cacheable. Write our own really crappy cache. Well, that seems hella faster. I'm kind of surprised how much faster this is. What? Why is this so much faster? Okay, I'm kind of surprised we're running the same key combinations into this over and over. And the same position. But again, I don't know how many this number is supposed to go up to. I don't even know like what the estimate of the time of completion would be. Also, is it still correct is the other thing. I wish there was one like slightly larger sample size than the ones that we have. It seems to still be getting the same results for that. I believe try acceptor slow, return cache.get or func should be faster. Try accepts are only slow on failure. You want to make your cache hit the fastest thing. You don't actually care so much about the speed of your failure. This is the fastest approach to caching. Or the fastest fast path is what you want to optimize for. And the try has essentially no overhead. X-Ninja Rose says, what's Advent of Code? Advent of Code is a series of programming puzzles that come out 2 per day in the month of December, a sort of advent calendar of programming, if you will. And, yeah, and I'm working on day 18, part 2 right now, and I have no idea how long my solution is supposed to take. But I'm running day 18 part 2 with my potentially really bad solution right now. Hey, what's up, Toddy? 5 a.m. Man, that's rough. But also, like, there's no way that this is the performance bottleneck of my code at all. Like, any function call is going to be well, any call to this function is going to be several orders of magnitude more expensive than a try except. A function call is probably more expensive than a try except. I also wonder why sometimes this slows down. But yeah, 4 minutes. It should have, like, some other people's solutions were like in a minute. So I'm still missing some case here. Hey, what's up, Juan Carlos? I'm working on what am I working on? Working on Advent of Code. I have a graph traversal problem, which I'm particularly bad at. I'm always bad at graph traversal for whatever reason. So I'm struggling hard through this one. Finished writing a new short blog post. Nice. Advent of Code gets complex sometimes. Yeah, this one is... I'm basically not... I think I'm not pruning well enough here. And that's my problem with graph traversals. I can never remember when the right approach to prune is. But I actually just thought of my problem. But why my pruning wasn't working before. I was pruning based on just the keys, but I also need to prune based on the bot positions. Because they could be in a completely different position at the same set of keys and get there more efficiently. So let me try that. What am I doing? I'm currently doing a bunch of depth first searches and then trying to prune them. Hey, what's up? Hey, thank you for the follow. Welcome to the stream. That's right, that's correct now. Now I get an answer. Is that really it? I just need to fix my pruning? Fuck, man. This is right. Be pretty excited, and then I'll clean up my code, and then I'll go to sleep. Then I'll jump on a plane tomorrow. Wow, even after all of that, I'm only 243rd? Damn it, man. I probably could have thought of that a couple hours ago. Prune is a funny word. Yeah, it is Peace Frog 71, but I got it. At least you solved it. That's true, Mediox. At least I clevered it out, and I didn't even need any hints. It just took me a while. I hyperfine for CLI quick bench. I don't actually care about the benchmarks at all. They're garbage numbers anyway. They're just supposed to be relative to other stuff. Okay, let's clean this up. Actually, let's see if my cache makes a difference now. I suspect it might, but let's we don't need to comment it out. We just need to comment this out. Well, it took 1 second last time, and it's taking a lot longer this time. 8 seconds versus 1 second? So the cache makes a difference. That's something. I avoid the cache, though. Why not? Oh, but type annotating that is gonna suck. Alright, that's not so bad. At least I got there in the end. But yeah, let's commit this code. I'm not gonna do a second language tonight because I gotta sleep because I gotta jump on a plane. But let's see what's up with this. Oh, I forgot to uncomment that. Gotta clean up this code because that doesn't matter anymore because we never even get to 1,000 completed ones. Let me make sure. Actually, let's put our test cases for part 1 in here, as they were kind of useful. Copying and pasting some code in here. VTCN says VBA, still waiting for the Excel day, right? I don't think I'm doing any of these in Excel. I could maybe do one of the older ones in Excel, but I'm not as hardcore as that other guy on the subreddit. That doesn't sound familiar. Day 18. Well, I guess that was right. B is 132. And input 4 is 136. Takes a while, but it does complete. And MN Roniasa says, tabs or spaces? I'm a spaces person. I love spaces. I really do not like those wacky tab characters. That's just me though. I'll run this a couple times. Aces hitting tab. Sometimes I will manually press 4 spaces, 3 spaces, or a couple spaces. Alright, I'm not running this 6 times. We'll run it 3 times, we'll pick the best of 3. Mediox, you liked... Wait. Can't stand how he uses space instead of tab. Oh, when I sometimes press space 4 times? Yeah, these are exactly the same. Python day 18 / part 1, day 18 / input.txt. But yeah, the days are about to get a lot harder than this. I remember last year there was one day that I spent like 5 streams in a row working on it. Then again, I didn't like follow the subreddit at all. I didn't have any hints, but it took me quite a while to get there. I like to think that I'm a little bit more clever about approaching them today than I was last year, but I don't know. Hey, what's up, Mr. Igor? Thank you for the follow. Welcome to the stream. Alright, line 9, we're missing a prototype. This is tuple int, and it returns generator tuple int none. Line 20, need annotation for grid. This is dict tuple int to stir. Line 31, need annotation for visited. This is set of tuple of frozen set stir and tuple int. That is not defined. I'm typing import set. We also need frozen set. Need an annotation for states. This is list of tuple of frozen set stir tuple int and int. Okay, passing my pie now. A little bit of a complicated type annotation for this one, but actually not so bad. In part 1, part 2 is going to be an interesting one to type annotate. Oh, we should put the tests into part 2. Oh, also delete all the dead code. This is all dead code. First one. Second one. And this is our third one. VTCN says, do you ever watch GeoHot for Advent of Code? He always finishes before me, so I haven't had a chance to check out his streams. And I barely have enough time to to deal with my own life than watch stream content or watch like post-recorded content. But I've heard some like crazy stuff, and maybe I'll have some time over the holidays to review some of his past footage. But yeah, I barely have enough time during my own stream slots. Like if I had free time, I'd probably stream it instead of I'd probably stream instead of watching streams, you know? Hope that makes sense. But I've heard that he's quite the or they, I don't want to assume pronouns. Assume they're quite the wizard. Okay, passing. We run the CPython. And that's quite a bit slower than PyPy for this one, but still actually pretty fast. Faster than my part 1. I guess we'll run it a couple times to get a best of something. This is 2 seconds, it's not actually that slow. Best of 5. Okay, 18, part 2. And okay. Do the same. What the fuck did I do to my terminal? Back now. That was weird. I pressed some key combination that caused everything to go off the rails. From typing, import generator. We'll also need tuple. So I know that one. Tuple int. So the same type of annotation as the other one. Generator tuple int none. So this is a thing that takes a 2-tuple and yields 2 tuples. Trace recursive. This returns none. At that part at least. Path is list of stir. Pause is tuple int. Hey, what's up, the guy Joker? Thank you for the follow. Welcome to the stream. And PeaceFrog71 as well. Thank you for the follow. Visited. What is visited? It is set of tuple int. And this is paths is list of tuple stir. Tuple stir. Trace keys. This is tuple int. Ethan says, "Wow, didn't expect you to still be streaming. It's late." Yeah, it's hella late. This is the last stream of the year, and I didn't want to leave it off on an unfinished note. So I'm banging it out before I have to go to sleep and then wake up early and go on a flight. But I enjoy it, so that's why I'm doing it. List, tuple, stir, ... And I'm doing your favorite part right now, Ethan. I'm type annotating. Is what? List of tuple. List of tuple stirs. Hey, yeah, we're getting some MyPie up in here. I'm about to be really sad, though. This function is gonna suck to annotate. And it makes the code, it actually makes the code way faster. Worst part. Like I could use this. Yeah, oh, decorators, right? I can use generics to make it slightly less terrible to annotate. Typevar t callable. I always forget the syntax though. I use this somewhere else. I know I've written a decorator before. Bound equals callable ... any. Oh, I used it in Babby. Huh. Well, or I could do the actual type signature. Or I could not have a decorator and do it here. Where's the return? Here's the return. Oh, but this is so much more gross. Oh, I know what I could do that makes this less gross. Hehehe. Dict, frozen set, stir. Stir and tuple int. Oh wait, oh wait, that's not the end. Gotta also put another layer of tuple in here to int. I hates it. I hates it so much. Frozen set stir tuple of tuple ints. And may want some aliasing. Yeah. It's fine, it fits. Oh wait, this is not tuple int. This Let's just tuple int int. That's slightly less bad. It's fine, it fits how bad code comes to be, right? I mean, that's usually my judgment for like how bad the type annotations are, is like, does it fit within my terminal width? It's probably fine then. Good enough for a punch card, good enough for me, right? 80 characters in 2019? What are we talking about? Visited equals set. What do we put into visited? Actually, we can get away by doing this, right? Does it still work though? Yes it does. Cool, saved a type annotation there. Line 86, incompatible return type, expected int but got this. Right, this is actually tuple of int and tuple int. I should really have used name tuples more in this. $97, no signature. Good thing it's the same as this function. Incompatible return value type. Got int expected tuple int on 104. Alright. Okay. You've convinced me. This is a bad type annotation now. It's too long. Okay. What are we doing here? Keys T equals frozen set stir. What else do we have? We have grid T. Dict tuple int stir. I can nest these, right? That's a thing? Okay. Dict chord T stir with grid T. Not that one. Need that one. Yeah, I bet like some of these fit on their own line now. Which is cool. Oh, this one's nice and short now. That's not so bad. It's pretty bad. Possible next keys. This is ET, and this is tuple stir. And this is generator, stir, none, none. I should probably use a type for paths, maybe? Yeah, let's do that. Paths T equals tuple, tuple, stir. Do I have key T? You're right. Thank you, Ethan. Paths T. Really? Oh, we have list here, not tuple. Interesting. We'll find out that that's broken in a second, though. This is tuple, tuple, tuple. This is tuple of paths T. Yeah. Paths is T. Basically. Generator has incompatible item type. Tuple, tuple, stir thing. Expected tuple, tuple, stir thing. No, I had a bug in my annotation, I think. Tuple, 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 sure. Right? Is that right? Yeah, I think so. Although I used lists because I was just cheating. I'm tired, I promise. Yes, you're gonna make me want to do this. Okay. Getting closer. 149. Oh, buddy. This one's gonna be a good one. EST. This is tuple paths E. Key count int prune is dict tuple key t tuple chord t dot dot mapped to integer. This returns integer. Keys t. 187. Need type for grid. Oh, we're getting close. Dict tuple dict chord t to stir. Argument 2 to run path as incompatible type tuple list tuple stir. Expected tuple 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 stir. On line 211. Oh, trace keys. And just do this. And then let's tuple. Actually, this is just paths T. Fuck yeah, my pie's happy. Make sure it still gets the right answer. Oh, sweet, sweet sleep. That was a bit of a struggle. Not gonna lie. Day 18, part 2. Cool. Did I delete all my dead code? I forget if I deleted all the dead code. Let's see. Definitely use next pause. We've definitely used trace keys and trace recursive. Definitely use get key. Do we use redo paths? We do. Do we even need redo paths though? That's the thing. Can I factor this out? What if we just pass paths in here? Still get the same result in similar amount of time? Why am I trying to optimize this? Unreachable. Yes, we still needs it. Okay, well, won't question the tests. That's all good. Alright. We're done. Okay, this has been the last stream of the year for me. I'm going back to Michigan where the internet is absolutely terrible, but I hope to see some of you in the new year, in the new decade, when I pick up streaming again in January. But yeah, I'll be picking up the rest of Advent of Code, so this is the last day that I can get points, because yeah, I'm not gonna be doing these the night of, or the rest of the damn, it took me 3 fucking hours to get to the second part. That's ridiculous. Hey, thank you Garp916 for the follow. Greatly appreciated. Happy end to Python 2. Yeah, I'm gonna be cleaning up a lot of my code, which I'm excited about, and just like purging that terrible knowledge from my brain. Then again, I still have Python 2.6 knowledge in my brain and haven't written that in years, thankfully. But yeah, if you liked what you saw today, I upload all my content to YouTube, and that's youtube.com/AnthonyWritesCode, so you can find all of my previous stream content, all of the other days of admin of code that I've hacked on, so you can see what solutions that I've checked out. Interestingly enough, the day that I think was the most interesting of all of the admin of code days was day 13, which has the smallest number of views. So I don't know, man. YouTube is weird. But yeah, check out that content if you wanna check this out. This one in particular I think is really cool because of the visualization that I did for this. Yeah, so here's, you can see some of the viz. Where did we? There's a part where we just like ran it in a loop. That. Here we go. Here. There we go. This is the visualization. So I thought this was really cool. Basically built a breakout game and then like ran it in curses and like, I don't know. I thought that was fun. But anyway, that was probably one of my favorite Advent of Code days. But I digress. Usually when I stream, but I won't be streaming until January, I stream on Saturdays at 11 a.m. Pacific time to try and be a little bit Eastern facing countries friendly, the European countries friendly. But I usually announce that in 2 different places. One of those is twitter.com/codewithanthony. Not Anthony Writes Code, couldn't get the same name. Turns out Twitter has a character limit, so it would have been Anthony Writes COD and not a fishing channel, so maybe one day we'll do a fishing stream just to be funny. But anyway, twitter.com/codewithanthony for that. I also announced them on Discord, which you're free to join. I just put the link in the chat. and check that out. But yeah, that's all I've got for today, and hope to see you guys around in the future. And this has been a lot of fun for me, and it's been a good year of streaming for me. I mostly started at the beginning of the year. Like I had done a couple of streams last year, but this year is kind of my first time doing it on a regular schedule and like getting in the flow of that, and it's been a lot of fun. I've really enjoyed it, and thank you all for being a part of that, and I hope to see you around in the future. But anyway, have a good one, and I'll go find someone to raid.